Let me tell you something. This is the best video you can ever find on the basics of circle geometry, right? It's going to be an insightful teaching. So welcome to Post Scholars channel. If you are preparing for NECO exam, WAEC exam, JAMB exam, or any other college exam, be rest assured that if you watch this video to the end, you will become a master in solving circle geometry, right? So let's dive in. Theorem 1. Remember, we are talking about circle geometry. In this video, we are not solving problems. I just want to introduce you to all the theorems, because if you don't know the theorems, it will be difficult for you to solve problem, right? So the theorem 1 says angle at the center, and this theorem says angle at center is equal to 2 times angle at circumference. Now let's illustrate. This is the first diagram. Angle at center. This is the angle at center, right? And this is the angle at circumference, right? I'll tell you the reason why we are not working with this. Now let's continue first. It says angle at center equal 2 times angle at circumference. That means if the angle at circumference is x, then the angle at center is going to be what? 2x. Now the question that comes to your mind is, how do I know that this is the... Why didn't I pick this as... Now the trick is this. You look for the arc combining both angles subtended at center and angles subtended at what? Circumference. Now this is the arc, right? You can see this is the arc. The angle at circumference, right, is associated with this arc. You can see it. While the angle at center is also associated with this what? With this arc. So that guides you on how to go about solving problem involving angle at center. Next is another diagram here. Where is the angle at center? This is the angle at center, right? And this is the angle at circumference. And the theorem says if this is x, if this angle is x, this angle will be what? 2x. That means if this angle is 30 degree, this angle is going to be what? 60 degree. Now how do I know I'm supposed to choose this angle and this angle? Like I said, you look for an arc that combines both center and circumference. Now where's the arc? This is the arc from here to here, right? You can see the angle at circumference is associated with this arc, right? While the angle at center is also associated with this arc. I believe it's well understood. So move on to theorem 2. Theorem 2 says angle in the same segment, right? That is, all angle on the circumference that stand on the same chord or arc are equal. What does that mean? First of all, angle in same segment are equal. This angle x is equal to this angle, which is what? X. Now how do I know? Very easy. Look for the arc associated with these two angles or the chord. Now this is the chord, right? Angle is same. This is the chord, right? You can see this angle. You can see that this particular angle is associated with this chord. You can see it's associated with this chord. While this other angle too is still associated with this what? With this chord, right? So that's why angle in the same segment are what? Are equal. Remember I told you what segment is. This segment here is the minor segment, while this other segment is the what? Major segment. And this and both angles are on the same segment. And not only are they on the same segment, they also share the same what? The same chord. So take note. Very, very important. Now next, theorem 3. Theorem 3 says angle in a semicircle. By now you know what a semicircle is. Half of a circle, right? Now this is the diameter, right, that pass through the center of the circle. So automatically the theorem is saying this angle here is going to be what? 90 degree, provided it's in a semicircle. You can see it's in a semicircle. Same thing, this also is semicircle. Automatically this angle is going to be what? 90 degree. You can see I'm representing with a small square because small square in geometry subtended in an angle represents what? 90 degree, right? Now next, theorem 4. If you are following, please do it to like. I want to be sure you are actually following, right? Next, theorem 4. Theorem 4 says cyclic quadrilateral, and it says opposite angles are supplementary. Supplementary means they add up to 180. Now this is cyclic quadrilateral. It simply means a four-sided shape is inside or inscribed in a circle. Now where is the opposite angle? So this angle and this angle are opposite one another. I can name this one angle A and this one angle B. Similarly, this angle and this angle are opposite one another. I can name it angle C and angle what? D. So the theorem is saying A plus B is equals to what? 180, and C plus D is also equals to what? 180 what? Degree, right? So that's what the theorem is basically saying. That means if A is 100 degree, for example, what will be B? B is going to be what? 80 degree. So that when I sum up 180, it gives what? 180 degree. Very simple. Now the next is exterior. Theorem 5 says exterior angle of a cyclic quadrilateral, and it says the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle, right? Now where's the exterior angle of this quadrilateral? Now cyclic quadrilateral, I told you, means a four-sided shape inscribed in a circle. Now this is the exterior angle of the what? Quadrilateral, right? This is the exterior angle. Now the theorem is saying this angle, right, is equal to the interior opposite angle. Now this is the interior opposite angle, right? So if this angle is x, this angle is also what? X. Or if this angle is equal to 120 degree, this angle is also equal to what? 120 degree. That's basically what this theorem is all about. Next, theorem 6, radius and tangent. It says the angle between a tangent and a radius at the point of contact is what? 90 degree. What does that mean? This is a tangent. I've explained what tangent is. This is a tangent to a circle, right? And this is a what? A radius. So whenever there's an intersection of a radius and a tangent to a circle, the angle subtended is what? 90 degree. Take note, if yes 90 degree, yes also what? 90 degree. So that's what theorem 6 is talking about. Next, theorem 7. Theorem 7 says tangent from an external point, and definition is the length of the two tangents drawn from an external point to a circle are equal. Now what does that mean? Let's illustrate. If there's a point outside, right, this is a point, and I draw a tangent to this circle, right, and I draw another tangent to this circle, right. Now this is the point of intersection for the first tangent. Let me label it A. This is the point of intersection for the second tangent. Let me label it B, right. So the theorem is saying that the length, let's label this one O. So the theorem is saying OA, length OA is equals to length OB. So let's write it OA, that's line OA is equals to line what? OB. So that's what the theorem is talking about. Then this other part says the line joining the external point to the center also bisects the angle, right? So if we have a center, like this is the center of the circle, then if there's a line joining the external points to the center, right, definitely the theorem says this line, right, is bisecting the whole of this angle. That means this angle is equal to this angle. That's if this angle is 30 degree, for example, this angle is also 30 degree. So that's what theorem 7 is all about. Now move on to theorem 8. Now theorem 8 talking about alternate segment theorem, and it says the angle the chord makes with the tangent is equal to the angle it subtends in the opposite part of the circumference. Now what alternate segment theorem is saying is that if this angle, right, this is the tangent, right, then this angle, right, let me name it X, is equal to this angle, which is also what? X. Now how do you identify this, right? To identify this, what you look for is the intersection, the angle subtended between the tangents, right, and a chord. This is the angle, right? Then look for the angle that this chord subtends at the other part of the circle. Where's the angle that this chord subtends? Look at it like this and like this. So this is the angle this chord subtends. So you also label it what? X. Now let's do the other way around. Let's label this one angle Y, right? So if this angle is Y, this angle is also Y. How do you clarify it? You check, this is the angle between the tangent and the chord. Then you now look for the angle that this chord subtends. Where is the angle? This is the angle. So you label it what? Y. So that's what alternate segment theorem is actually talking about. Now move on to theorem 9. Theorem 9 says chord bisector. It's talking about chord bisector. It says a line drawn from the center of a circle perpendicular to a chord bisects the chord, that is, it cuts it into two equal parts. What does that mean? This a chord by now you know what a chord is, right? And this is the center of the circle. Any line coming from the center of the circle and bisecting the chord into two equal parts, right, forms 90 degree or subtend 90 degree in between them. So that's what the chord bisector theorem is talking about. I think these are the theorems you need if you want to solve any problem involving circle geometry. I believe it is well understood. God bless you. Wish to see you in my next video, and bye.